Hey guys. Okay, we're gonna test some sensors today. Now that we've had that big overview, we're actually gonna do something. Let me just say I've increased the resolution of my videos so you can actually read what will be on the screen in the editor now. I know it was a little tough on that video where we did the nightlight, and I don't know how many sensors we're actually going to get to cover today, but we're gonna try to go with the simpler sensors first, the ones that give us analog feedback. The PRI is probably going to give us digital feedback, which is either high or low, but we can use an analog pin to read it. We're going to try to do the infrared sensor, the sonic sensor, the PIR motion detector, and the joystick. So without further ado, let's open our processing sketch. Okay, we're not going to reinvent the wheel here. So what I'm going to do is I'm going to open the nightlight sketch. And when I complete this sketch, I believe I will show them in the notes below the video. We may make some changes. I'm going to try to have make this sketch so that we could use the same sketch with each of the sensors. There might be a little different feedback depending on which sensor we're using, so I may have to make modifications. But at the very least, I'll post one of the this code. I mean, you could read the code and you can type it out yourself. You can hit pause, but and you really shouldn't copy paste because you really don't learn it. It doesn't sink in unless you start typing it out yourself. But just in case you're typing it out yourself and you make mistakes or something, it'll be good to have the working code. And I'll post that in the show notes below. Okay, let's do a little review of our nightlight. Init light, nightlight. This, again, is a variable. We're using variables here. Init light sensor. So the nightlight equals 13 because we're using pin 13. We're no longer going to use pin 13. That actually has a resistor. We're going to use some digital pins without resistors, and we're going to put resistors in. And we're going to have some LEDs and a buzzer for feedback because I'm going to have external video as well as this desktop video. And I'm going to combine the two. So, and then we have the light sensor, which is 5. But we're actually, let me save this as something else. I guess maybe we could do the infrared first. IR sensor. So we save that. So actually, we could just call this sensor if we want. Now keep in mind there are some, I don't know if I mentioned this last time, but there are some variables that are reserved by this code that you can't use. Like you couldn't call something else. And generally speaking, if you accidentally use one of those, it will appear as another color. So you'll get the idea. And actually that should be a lowercase. Sensor, and actually let's call it IR sensor right now. And I guess we can continue to use analog pin 5. And it sensor value is 0, so that's the sensor value, so we'll keep that the same. Init light strength. We're actually going to get rid of this line because we're going to have a series of things. We're going to have a green, a yellow, a red, and then a buzzer sound depending on the strength of the sensor, or the I won't call it light strength, but the sensor strength. And now see what this is going to change because we're going to use a bunch of if statements. So we could actually have something here and then do times 1, times 2, times 3. But I think for now what we will do is we'll use numbers and then we'll go back and then we'll so I'm going to delete this for now. So we're going to use numbers and then we'll go back and see what we can do to create a variable for it. Once again, just a quick reminder, if you don't know what something is, come in here to the help and it will help you. Let me see something here, if it has Switch case, yeah. We're going to be using if-else, but you're going to see a lot of people tend to use switch case because they come from C code. The reason why we're going to be using if-else is because we're going to do processing too. And I don't believe switch case is available in processing, but I know if-else is. So I'm going to try to make the code as portable as possible between the Arduino and the processing, which I don't think we're going to get into processing today. But okay, let's go back to our code here. So we have our light sensor. We have, our night light, pin 13. So we need to change this. So we're going to call, what we're going to do is, I think we're going to use digital pins, but we're going to use ones that we can turn into pulse width modulation later on. So we're going to use pins 9, 10, and 11. So 9, 10, 11, and 12. 12 is actually not pulse width modulation, but we're going to use that for our buzzer. So we've got 9, 10, 11, 12. So let's say green LED is 9. Yellow LED is 10. So we'll be able to convert these over to pulse width modulation pins very easily. I don't think we're going to get to that today either because I want to cover, again, pulse width modulation. And I didn't prep for that. But we'll be able to use this same code because we're already using pins that we can use for pulse width modulation. And instead of having a digital write high, we can have an analog write and then do from 0 to 255 depending on how the strength of the light. So this will be our red LED. Now normally when you're creating variables, you notice how I have two caps here? And I have, these 3 letters caps. Usually when you're creating variables, what you want to do is you want to have, and I mentioned in the code after every command you have a semicolon. I don't know if you could see that in the other video. But basically each word, you start with the lowercase, and then each word after that is capitalized, and then it's lowercase after that. That's basically the standard. Like here, night light. If I had night light bright, then there would be a capital B for bright. So normally you don't do what I'm doing right here. I just wanted to point that out. I'm actually doing it because it is what I would do. I'm not going to be a hypocrite. Okay. And 12, which can't be used as a pulse width modulation, but we're actually going to have a buzzer on that. I had mentioned before about the piezo buzzers. You need to use pulse width modulation for those. And piezo buzzers are nice because you can change the pitch of the buzzer using the pulse width modulation. Where a regular, so you have to use, if you just hook it up to a digital pin and bring it high, a piezo buzzer won't make any sound. You'll hear a little click, and that's it when it's thrown high. So we're actually going to use a buzzer. We're going to keep it simple at first. We're going to use a buzzer for, we're going to have our green light light up, then our yellow light, then our red light, depending on the signal strength as the signal increases. And then, let me see, green, red, oh, sorry. And this will be our... Actually, I think this buzzer's more like a siren. It's very, very loud. Okay, so here's some of our values, our variables, sorry. Okay, so we have pin mode. Now we've got to make all these pins outputs. So we already have a pin mode here, and Arduino code for nightlight, Arduino code for IR sensor, and initialize the digital pins as outputs because we're using more than one now. And it's pin 9, for green. We probably don't need this level of detail since, you know, we named it green LED. Pin 9 for green. Actually, let's pin 9. We don't need to say green. Pin 9, 10, 11, and 12. 9, 10, and 11 for LEDs. 10, might as well make it legible. 11 for LEDs and 12 for buzzer. Okay, and these are all going to be, I have this giant screen here. I should use more of it. So these are all going to be outputs. So basically, before I do anything else, we've got 4 of them. So, and we got green LED, yellow LED. Now I could type these out in here, but if I do a typo somewhere and they don't match, it won't come on, and I'll get an error. Actually, we'll do that for buzzer. Let's type in buzzer and let's leave out Z so you can see what happens. Okay, so we have our outputs. We want to have our serial on, and I noticed during the Nightlight video, I don't know if you could read it on some TVs if you were watching Vimeo on a TV, because it was all the way over to the left. The serial monitor was all the way over to the left. Of course, there's nothing plugged into the serial port right now. So, and save your work often, by the way. Constantly save it. It's hard to do a lot of code and then have to reprogram all that code again. Okay, so, but when the serial monitor, I'll make sure it's more towards the middle of the screen. I apologize for that. Okay, so we have our outputs. Now, the PIR sensor may have a digital input that we're actually going to do a digital read instead of a digital write. But I couldn't find the data sheet on that, so we're going to actually hook it up to the analog pin and see what kind of output we're getting on it. I don't have my oscope on me, so if it was some kind of digital output, I couldn't see that right now. But anyways, okay, so we have those, and we remember the analog pins. We don't have to say analog pin output, pin mode. These pin modes are for digital pins. So we have sensor value equals analog read. So we still have sensor value. Analog read light sensor. Now you notice, see here, we're doing this. Now if I compiled this, it would tell me, boom, right there. Light sensor was not declared in the scope. So I never declared a variable called light sensor because we changed that. So what we want to do is we want to put IR sensor in there. I know I should be typing this code out from scratch for you guys, but I want to get a lot of information in here. Sensor value. So we're actually going to print out the sensor value to see what the value is, because 2 of our sensors that we're going to be doing today actually have analog. One of them we could actually do pulse width modulation output, or so we could read the digital pin for it. As well as, I don't know if it has a serial on this particular one. But today we're going to be using the analog. It's the simplest, and it works great. I actually like the analog outputs, and I prefer it over reading the bytes of some of these other sensors. But we're going to get to those as well. So we're going to print out our print line. So we've got our serial begin. If you remember, that's how we're doing serial communication. And so we're printing that out. Now we have, okay, now we're going to have our if-else statements. And we're going to use, I think we can use else if on this as well. That's why a lot of people like the switch case, because it goes through each individual one and it just grabs the one that you want. But I think we can do else if on this. So basically what we're going to do is we're going to have a series of if statements that, if the sensor is greater than this, turn on the green light. Well, if it's greater than this, turn on the green and red light. If it's greater than this, turn on, the green and yellow light. If it's greater than this, turn on the green, yellow, and red. And if it's greater than, if it's at the highest, then we want the buzzer to come on. But we don't know what kind of reading, what kind of feedback we're going to get from these sensors. I mean, we could say it's going to be 0. It's 1024. If the scale is 0 to 1023, which is 1024. So it could be anywhere, but I found a lot of these sensors don't actually give back feedback to the whole 1023. Very rarely do you actually see that. So we want to get an idea of what the feedback is going to be from the sensor to decide at what level we're going to do the different things. So we're actually going to write the code first, and then I'm going to rem it out. So we're actually not going to use it until we get our sensor values, and then we're going to put values in there. So right now I'm just going to put value of 0. And we don't have a nightlight anymore. We have green LED. And so if sensor value is less than 0, we want if sensor value is greater than 0. And what I could do is I could do if sensor value is less than this, just put on the green light. But I want to start introducing you guys to these comparison operators, which is equals, equals, not equals, less than, as well as the Boolean operators, and, or, and not. This is, of course, like not equal to, but we're going to use and or in our code today. So let's get back to here. And so if sensor value is, let's say, greater than, and we're just going to put some guess numbers here. If it's greater than, we don't want anything to come on unless it's greater than 10. Or actually, you know what? Let's we're writing this code on the fly here, guys. So if it is less than 10. Now there's going to be, we're actually going to edit this code again, not in this video, in a future video, because what you do is you write out your code and then you go through it and you clean up your code. So if it's less than 10, we want everything to be low. So let's copy this a couple of times. So at first, our code doesn't have to be very efficient. Oh, we need one more for the buzzer. And we'll misspell buzzer with one Z here. So we had two Z's up here, but we'll misspell it here with one Z. And then we could do else if, and this is where we'll find out if we could actually do this. sensor value is greater than 10 and sensor value is less than, let's do 150. Then do this code, which is going to be, we're actually going to copy this. We got to turn on our green light. Now I could take this. I'm just doing this for time, guys. Otherwise, I'm going to have 50 videos up here. And let me just put a space in between these. And okay, so now we have 150. So if it's greater than 150, oh, we actually have to be careful. 149. If it's greater than, oh, I'm sorry, and this should be a less than. So up here, sensor value greater than 10, less than 150. Well, see, you got to be careful. There's on these, the reason why I got 149 here, because if it's less than 150, that means 149. If it's 150, it won't work. If I did less than or equal to, then we could use 150 on all of this. And actually, I think that would be cleaner code, so I guess we could do that. Let me see. See, we've got less than or equal to. Greater than or equal to. If we just use the less thans and greater thans, then this one needs to be 149. So we're going to say if sensor value is less than 10, and if sensor value is less than or equal to 10, keep everything off. I'm sorry. Less than and equal, less than or equal to 10, keep everything off. If it's greater than 10, it means 11. This isn't going to go off at 10. And it's less than or equal to 150, then green light goes high and the rest are low. Now down here we can do greater than 150, which is 151. And then less than or equal to, let's say, well, let's do increments of, you don't need spaces between this stuff, by the way. I just put it in there to make it readable. Then the yellow light will come high. Do I have voids set up? Okay, this is actually going to require... Okay, we'll get to that in a minute. Okay. I need another one of these guys. Okay, so if sensor value is greater than 150... Oh. Okay, and sensor value is less than or equal to 300. So if it's in between those two values, these have to, when we use the and for Boolean, it says this condition and this condition has to be met to run this code. If we use the or, wow, I've got many Arduino references up here, huh? Probably more than I need. If we use the or, which is the two bars, it's above, if you use the shift and then above your enter key is that line. That's what the or is. If you use two of those, then if this value is true or this one, then it will work. We want it to meet both of these criteria. That's why we're using an and instead of an or. Okay, so now let's take this. Actually, I guess I didn't need to put another one there. I could just go like this. And let's keep it readable. Okay, so now we have, if it's greater than 300, okay, so if it's greater than 300 and sensor value is less than or equal to 450, once again, these are guesses. We've got to see what the range of our sensor is. Then we want the green light, we want the yellow light, and we want the red light. Now, why do we need this one at first? Because if it meets any of these conditions, we won't have a condition where everything is off. So that's what this one is for up here. Okay, so if it's greater than 300 and the sensor value is less than or equal to 450, then we have the green, the yellow, and the red light on. These are curly braces, by the way. You should be able to see them now that I've upped the resolution on this. Okay. Now we're going to have greater than 450 and equal to or less than, we'll just put 1023. That's as high as it can go. We don't want a condition where we get above a certain number and then nothing happens. Okay, so now we put our ending brace for this. And this is our ending brace for the, see if we go, see how it shows us the matching brace here? If I go here, it shows the matching brace for this one. So these are for these if-else. And then this brace here, this brace here, I don't know if it'll flash off. Oh, there it is for this guy up here. So this our function void loop is contained within a brace. So basically the braces, what they do is they separate our code. And okay, so we've got this, and I think we might be good to go. Let me see. So let me save this. And I can't compile it yet because I don't have the Arduino plugged in. But you know what? I'm going to plug the Arduino in anyways, and then I'll put in the I'll put on the feet after it's plugged in. That way, at least I can run this. Okay. Hopefully you could hear me. The mic was down low. Okay. Serial port COM4, the board, yep, I got the correct board in there. And let me save my code and let me run it. See? Buzzer without that extra Z. Buzzer was not declared in the scope. Well, there it is. Yeah, but it's minus a Z. Okay. Now let's save it again. And compile. How did that happen? Oh, see, I copied paste everywhere. So I guess copy paste could be detrimental too. I suggest you write out this code. When I was first starting, I would write out this code all the time. And now let's compile. And we have a successful compile. Does that mean the code is going to do what we want it to do? No. By no means. Because if we mess these numbers up here, and we're going to change these numbers to variables. So later on, we only change one number up here, and for the different sensors, and it changes all our code. So our code is good. I guess we should go build it now. Actually, I am going to upload this code. Let me just make sure. See, here's the serial monitor. And this is from, it's reading there's nothing plugged into the Arduino, but it's reading that other sensor. And it's reading it pretty fast. I think I might put in a delay statement in here, just so it doesn't run this fast. Actually, I don't know how visible that is for you guys, but let's put in, let me see. Let me make sure delay is for, yep, delay, milliseconds. Just making sure the delay was for the Arduino as and not the processing. Okay, so we print it and we'll delay it 1 second. So we'll have a delay. Now remember, this is in milliseconds, so it's 1,000 milliseconds equals a second. So now if, let me save my code, let me compile it. Let me upload it. I'm uploading it to the Arduino, because if I looked at that serial monitor right now, it doesn't have this code on there. So it's still going to be reading the same sensor value. Okay, we've done uploading. Now let's open our serial monitor and see, now we're getting something, you know, a little more readable. Now, unfortunately, if I wasn't doing this video, I would have it go very fast, because then I could see the differences in the variance of the read much better. You know, because this is a second, my hand can move. If I'm testing the distance, my hand can move, you know, very far in 1 second, even if I'm moving very slowly. But we'll keep it like this for now. Okay. Okay, so we've uploaded our code, and now let's go build it. Okay, guys, now it's time to build. I might have this camera too high resolution. These videos get outrageously large. But I want you guys to be able to see this stuff. Okay, first of all, this is the Arduino, which I'm sure you're all familiar with. And before I do anything else, these are some feet. Sometimes they come with the Arduino, depending on who you buy it from. And they just pop off, and they're just, you know, glue on the bottom. So that if you notice the bottom, if you put it on any metal, you could conduct and you could actually blow your Arduino. So I'm just going to put these feet on here. And these actually aren't the feet that came with the Arduino. This was something else. So, but I just want to keep this off of of anything in case I actually put it on some metal. Okay. And if I put it on the pins, it wouldn't make a difference. Like this rubber isn't going to make a connection on the pins, but it may not stick as well. So I try to put it, you know, not necessarily on the pins. Over here, I usually don't have a choice. You know, if it was a smaller rubber thing, then fine, but it's not. So this is actually, let me see. Put it here. Okay. Yeah, sometimes it has a tendency to come off if you put it actually on the pins. So, now, I showed you the Uno with the pulse width modulation. This is the Demulov. And you see it says PMW for pins 9, 10, and 11. Yours will have a tilde. It'll say pulse width modulation with a tilde, you know, the little curvy line. And then it'll have the curvy line next to each pin that's capable of pulse width modulation. So we're going for analog in 5. And we're going to get power for our sensor here. And sometimes I've had to reboot my computer if it's just running off of this power, because the sensor's actually taken too much power, and for some reason it shuts down my my USB port, and I've actually had to reboot to get my USB port back. So one of the things I'm going to do now, I'm not sure whether this Demulov, whether it's going to make a difference when I plug in the 9-volt battery in here. The old ones, you actually get to choose which power source to get the power from. I'm hoping it by default it takes it from here and not the computer, and then just uses the computer for communications. So I'm going to plug in a 9-volt battery into this as well, just to make sure, because some of the more powerful sensors, this one probably wouldn't do it, but may affect my USB port negatively. Okay, so Here is our Arduino, and we have power for our Arduino. And I found usually a 9-volt battery, depending on what electronics I have on here and what I'm powering, usually will last about an hour. And like you've seen before, I have some rechargeable 9 volts. I need to get some for here as well as the Robotics Club. Okay, so I started putting this together, and we have a green, a yellow, and a red LED. Very powerful LEDs. I wish I had lesser ones here, but I don't. I could use these, but we're going to save this. I know a lot of you guys at home probably don't have these right now. We could do a whole series of LEDs, have like 5 or 6 of them, you know, to light up based on our sensor. Or we could have these come on, and we would just adjust our code. We just put more if-else statements and divide things up better, and you'd have a whole series come on based on the digital pins. So here we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And later on, as we go on, I'm going to teach you, we'd have to use 10 digital pins for this. But there are ways around that. You don't have to use, you could use shift registers. And we'll do that because we're actually going to get into that, into the electronics portion. I don't know if you've noticed, but I've actually separated the Arduino tutorials and the electronics tutorials. So it's the Italian in me with the talking with the hands. I've separated them. So they're 2 different channels. So if you go to, you know, my Vimeo, I think it's vimeo.com/electron, you just click on the channel you want, the electronics channel, the Arduino channel. There will be a processing channel. But anyways, until you guys get some of these, I don't want to start using a bunch of stuff that you don't have around. You can feel free to purchase these and experiment. But we're just going to do some basic sensors. So, and here's that buzzer I was telling you about. And this buzzer will work on 2 to 24 volts, and it doesn't have to be pulsed. So it could just have straight 5 volts. And I looked at the data sheet on it, and I believe the maximum draw is 20 milliamps. So we're not going to have an issue. Now let's take a look at our LED lights. Now, the LEDs, now, like I mentioned before, some of these things, you see here, my voltage, I can have 4 volts on these. And I actually use some of these LEDs in work and at the Robotics Club. And one of the guys was like, oh, no, I mean, we were hooking up LEDs to 3 volts without resistors. He said, you can't do that, you can't do that, you need a resistor. And they're perfectly fine because, you know, these guys will do 4 volts and, you know, max of 120 milliwatts or 25 milliamp max. I mean, so these are some powerful LEDs. Most LEDs you're talking about anywhere from 1.5 to 2.5 volts, but you can run them on a 3 volt. Even those ones I've run on direct 3 volts, they're not going to last as long. You know, if it's rated for, you know, 10,000 or 100,000 hours, you may cut that life in half or even a quarter of the original estimate, you know, by powering it with more voltage than. But I've generally found that they don't instantly burn out. So these are some of our, and it's different for the different colors. I mean, we've got a 5 volt max for the yellow. So, you know, it's different, but always, if you got data sheets, read the data sheets. We don't have a data sheet for this guy, so we're flying by. This is the PIR motion detector. Any of these guys, this guy can be used as a motion detector. This guy can be used as a motion detector. But first we're going to do the infrared guy. So let me strip these wires. I got my handy dandy wire strippers here. Actually, I should have done that as part of the prep. And I'm hoping these are solid core because they'll work better with the, well, quite frankly, with everything that we got going on here. And I'm just stripping the ends of the wires using wire strippers. No, they're stranded, but they're actually they don't seem too bad. I don't think I will have too hard a time with these guys. Especially with these stranded ones, you want to use the wire strippers. You wind up cutting off a lot of the strands, and then you can't do anything. Generally for my projects I'll tin the ends of these, which is just run some solder on it. So here's our sensor, and actually I should have went over the data sheet on this first. I guess we'll run over the data sheet afterwards on this guy. I meant to do that for this guy, to run over the data sheet. But I don't want to go back to the PC and do that video. I know when I know what can do this. Okay, so we're not going to need a pull-down resistor for this guy. So this is nice and easy. This is very easy. You've got an infrared LED in here, and then you've got one of those infrared transistors as well that detects the amount of light. And it's actually a little more electronics than that in here, because it'll actually give us an analog reading based on the distance that it measures. So I don't know whether it's got a time delay in there, it detects the time delay, or if the infrared light is pulsed or not. But it doesn't matter for the purposes that we're doing. Okay, so what I'm going to do is I'm going to put the red into the 5 volt. So we've got reset, 3.3 volts, 5 volts, 2 grounds, and then a volt in. So if I went to the volt in, I'd be getting 9 volts right now, because that's what I have plugged into the Arduino. So, but we're actually going to use, and then we'd actually destroy this. I think the max is 5 volts on this, or 7 volts. So that's in there. Now we're going to put the black. So we've got the red into the power. We're going to put our black into ground. And then we're going to put our analog into analog pin 5, I believe is what we used on our code. So right now he's sensing. This guy is sensing. And so we're going to put him aside for a minute. And now we need to build out our output. And this is going to be a basic output that we're going to use for the majority of our sensors. I mean, we can't use it for the clock, of course. Or actually, we could, depending on the time. We could light up different lights. We could change the clock. Maybe we'll do that. We'll do a little project where we have 12 LEDs for the hour, and then we'll increment 5 minutes or something. I'm not going to have 60 LEDs for the minutes, or we can come up with some kind of code that only we could read. They actually have LED clocks like that, where you have 3 sets of LEDs. But anyways, that's another project. So. Okay, so we have our infrared sensor. Now we have our green, our yellow, our red, and our buzzer. Now, if you remember, we used pins 9, 10, and 11 for the LEDs, respectively. 9, 10, and 11 is what we're hooking these up to. And unlike pin 13, when we did the night light, pin 13 has a resistor. These don't. Now, I could probably get away without resistors for these guys because they're so powerful, but I have 270 ohms resistors for these. I'm just going to put them in there anyways, just to protect these, because these are expensive LEDs, so, and I don't want to burn them out. So I'm actually going to use a green. Let me see if I have a long one. Green, yellow, and red for our different LEDs. So basically what I'm going to do is I'm going to come off of pin 9 with the green, and I'm going to come over to, okay, the green LED is in A5, so I'm going to come over to J5 with the green, and then I'm going to span the bridge with the resistor. If you haven't watched the electronics videos, go back to vimeo.com/electron and watch those guys, because I'm not going to re-explain resistance and how I know what resistors to use with what LEDs, and which is one of the reasons I didn't want to separate these. So yellow is 10, so I put this into 10. Now the yellow light is in the positive side. Remember, long side positive, short side negative. The flat edge is also negative. And I put that in 14. and then ground. So the long end in 14 and the short end in ground. So this guy is A14, so I'm going to put him in J14. And then our red, we're going to go from pin 11, digital pin 11 on the Arduino, over to, now the red guy is in A22 and then ground. So his positive side is on in A22, and then, so I'm going to put this into J22. So A22 to J22. Now I'm going to take these resistors and I'm going to span the gap between these guys. And we may have actually something come on. I should have power off to the Arduino before doing this. And if you only have one Arduino, please unplug your Arduino from your PC while you build this. You know, I don't want you guys blowing up your Arduinos because you're following me exactly. Okay, so the first thing I'm going to put this resistor, and there's no polarity on the resistors, so it doesn't matter how they go. I'm going to put in F5 and D5. So there's the green light. And I don't know, maybe we're not reading anything, because I would have thought the green light would have come on. Okay, so... Oh, we're not running to ground yet. We don't have anything to ground. Okay. Next, what we're going to do is take another resistor, and I'm going to put it in F14 and D14. F14 and D14. F14 and D14. Yeah, we don't have a ground yet going to ground. And then the last resistor, I'm going to put, for the red LED, I'm going to put in F22 and D22. I put it in E22, but it's just easier to span this. New breadboards, you notice we got a ton of new breadboards here. Because I know I'm going to need multiple breadboards for a lot of the projects that we do. Okay, so we have our infrared sensor is going from... and other infrared, like fluorescent lights and stuff, may interfere with these guys, by the way. I just thought I'd mention. We've got positive 5 volts, and then we have going to ground, and then we have the white wire going to our analog pin 5. We have our green and pin 9 going to the resistor, going to the LED, going to ground. We haven't put this ground rail to ground yet, which is why nothing's coming on. We will do that in a minute after we finish review. So pin 10 is the yellow wire, and that's going here, and we go through our resistor to our positive side of our LED to the ground side of our LED. And then the red wire is in pin 11, and that goes from pin 11 over to the resistor, over to the positive side of the LED, to the ground side of the LED. Now we have our buzzer. Well, we want our buzzer to be included in this too. And our buzzer runs, we don't need a resistor for the buzzer. It won't, the most it takes max is 20 milliamps, and it can go from 2 to 24 volts, and we're pumping out 40 milliamps at 5 volts from our digital pin, so we actually don't need a resistor for that. So what I'm going to do is I'm going to plug in one side of this is going to be in row 30, column, so 30F, and then I'm going to put the black end over the ground over to that ground rail. So this guy, our buzzer, is in now too. So he's all set, except for he is going, and I'm going to use, I should use a different color wire. I'm going to use a orange. I'm going to use an orange wire, and I'm going to go from pin 12, which is not pulse width modulation, over to J30. So that's what's going to power our buzzer here. Now everything's set except none of these guys, this ground rail does not go back to ground on the Arduino. And let me just mention to you, you see how you have, see how we have this being powered off of the Arduino power pins? If we powered this from another power source and put this into the analog, it wouldn't necessarily work. I've had sensors that don't work unless it can drain through, unless it has the power connected to the same power as the Arduino. So, and we'll go through that actually when we get to one of those sensors. So, but this, where we power it, where it requires more power than what we're going to get from the Arduino, we'll deal with that. Because it's very easy to deal with. You just got to make sure your ground is connected to the ground on the Arduino as well. Okay, so right now we have this guy. Now we want a big long black wire, if we've got one. Yeah, we've got one right here. So now we're going to take our ground rail, and remember there's two grounds over here on that Arduino. So we're using one, and now we're going to use the other, and ground. Second ground. Okay, so we've got something going on here. Our buzzer's not working. We're going to have to work on that. But, so we've got our sensor, and it's green, because it's not less than 10. Oh, right there, the yellow comes on, and then the red comes on. And I never actually hear the buzzer come on. So it's actually pointed up at a light. So let me point this somewhere else. So we've got green light. As my hand gets closer to it, we've got yellow. And then even closer, we've got red. Red. But let's actually see what's going on here with our let's see what kind of readings we're getting, because maybe we're not getting enough reading to kick off the buzzer, or maybe this buzzer isn't what I thought it was going to isn't doing what I thought it was going to do. It's supposed to work on 2 to 12 volts. So let me take this buzzer out. Let's see what happens if we hook it up to 3 volts. No, it's working at 3 volts. So 5 volts from that digital pin should work. So maybe we have something wrong with our code. Well, maybe the sensor isn't reading what we thought it was going to read. And once again, I'm bringing my hand down over the sensor. Oh, yellow, yellow and red. There's yellow. So we're going to have to make some adjustments. So I'm going to bring this sensor over here so I can reach it from the laptop. And I'm going to stop this video for now. Okay, we're back over to the computer, and I see one green light on. So let's open our serial monitor. Now, if you remember, we put that delay in there, and I think that's what was causing these. You remember I had to move my hand very slowly on that other part of the video. So if you notice, we have my hands is over that sensor right now, and I'm bringing it down. There's 169. And now yellow's on. And I'm slowly bringing my hand down more. 300, 400, 500, 600. So we see all of them on. Let me take out that delay for a minute. Let's shut this down. And let me take out that delay. Or at least let's bring it down to 100 milliseconds. And we'll re-upload. Now I hit the upload button, and it should upload our reformatted code. Let's look at our serial monitor now. So yeah, that's a lot faster. And there we have the green. And now the yellow light is on. It's going between yellow and red. So we've actually got to give some distance for this. So at our so basically, with me not even touching it, it's around 50. Let me see if I face it away from the lights or from other things. Oh, there we go. Now it's at a good distance, and yeah, I think lights might be interfering with it. I've got it facing over towards the fish tank right now, towards a wall. you work with these sensors yourselves, and if I was actually working and wasn't just doing a tutorial with this sensor, I'd probably have it so there would be a great distance. No matter which way I point this, I've got the camera tripod, I got the computer, I got the fish tank. Up high, I've got the lights. I can manage to get it down a little bit so the green light is off. But let's adjust our code. Okay. So now our code, let's do less than 100. We've got nothing. And here we'll do sensor value. So this is less than or equal to 100. So we want greater than 100. Greater than 100, the green light will come on. Now, how are we going to do increments? Well, let's look at our sensor again for a second here. What was our maximum? It looks like we have... Once I get okay, my hand is slowly going down on the sensor. We hit 600, but then it reaches a point where the distance, see now it's going, the numbers are going down again, but I'm moving my hand close to the sensor. So let's go look at the data sheet. This is the guy here. I'm using the one. Remember, it's got it's the beam is not as narrow and it doesn't have the distance. So let's look at the data sheet on this guy. And you should always look at your data sheets before doing this. I've dealt with these sensors before, so I wasn't overly concerned about this guy. So supply voltage is minus 0.03 to plus 7 volts. So it's not... So the 5 volts that we're supplying, it is well within their operational parameters. Let me zoom in on this a little so you guys can see it better. Here we go. So as you can see, the supply voltage, and we're supplying it 5 volts. What else do we have? So this is the operating temperature, storage temperature. We're not overly concerned with that. Output voltage. Well, we know we're not getting all the way to... it will give us our incremental voltage based on a distance. But we're not, since we're reaching like 600, what I'm looking for here is the operational range. Let me see if it has that here. Here we go. Recommended operational conditions. So operating supply voltage, VCC. If you remember back from on our electronics, VCC is plus volts. It's anode plus volts, and it goes 4.5 to 5.5 volts, and we're actually supplying this 5 volts. So I don't know what this absolute maximum ratings. So we don't want this. We don't want the absolute maximum, because this is like, well, you can reach 7 volts before you blow up the unit. So, but it shows here VCC 5 volts too. So this is what we want to look at: 4.5 to 5.5 volts. So, and we're well within that operating range. So this is our centimeters. So our max, we have minimum of 10 centimeters to a maximum of 80 centimeters is our range. And if we look back here, these guys gives us this before we even go into the data sheet. SparkFun actually gives us some information on this. So it's an analog output that varies from 3.1 volts at 10 centimeters to 0.04 volts at 8 centimeters. Or 80 centimeters. And actually, I don't think that that's accurate. I think that's the opposite. Let's go back to the data sheet. Okay. So analog output voltage versus distance. So distance is in centimeters here. And the reflect ratio is 90%. And so we slowly increase. So once we hit 5 centimeters, and then we go down, our voltage slowly goes down. Based on the distance. So if you noticed, when my hand was getting closer and closer, so when we were less than, say, 5 or 6 centimeters, remember how we saw the analog voltage actually was starting to drop again? So basically, our operational range seems to be like 6 or 7 centimeters. And then as we move further away, the voltage drops. So we drop from 3 volts out to less than half a volt. Okay, so that's how we need to read this is, and it looks like I'm going to have to do a video for each one of these sensors because this video is already getting kind of long. Okay, so this is how we drop out, but the other sensors will go a little quicker because we'll still have to do operational. Because there'll be differences. So basically, let's do some adjustments now. So basically, as I got really, really close, less than 6 centimeters away, you notice that the voltage started to drop again. Let's bring up our serial meter, and you can see exactly what I'm saying. Okay, so I'm moving my hand closer and closer to this guy. As I get closer, we see that the voltage is increasing, and then once I reach a certain distance, it starts to go down again. I'm actually getting closer to this, but this voltage is going down. And that's what we see here. I'm actually, as I get closer, this is the direction of closer, this direction. So this is further away, this is closer. And once I reach this, then it really starts to drop as I get closer and closer. So, these data sheets can come in handy for that kind of stuff. Feel free to read the whole data sheet. I did. I actually don't like this sensor. I like the one with the narrower beam, and I use it for robotics vision. I give it 2 eyes, and we're going to get into that. We'll deal with the robotic vision and all that other stuff. And I guess I can show you guys quickly. Sketchbook, my stuff. We're going to get into the robot builds and whether the motors move forward or backward based on sensor information. So I use 2 RF sensors, but I use the narrower beam. So if you're going to buy some of these things to do, you can actually come back here, and instead of buying this one, you could actually buy this one. This one I prefer. It's got a narrower beam, and it's got a better distance on it. It goes 150 centimeters instead of 80. So it's basically twice the distance you're getting out of this. And its operational volts is from, between 4.5 and 5.5 volts, just like the other one. So if you're going to buy one, this is the one I recommend, and I don't recommend the other one. And of course, this will have a document as well. And here we go. This is, let me zoom in on this. Once again, once you reach a point where you're getting so close to it, now this is about 15 centimeters away. So if you need something very close, then the other one is better. So once you get 15 centimeters, within approximately 15 centimeters, then your voltage starts to drop dramatically again. So basically the range of this guy is from 15 centimeters up to 150 centimeters. And of course for the States we'd translate that into inches. And but this is our voltage readings again. And what is this? Inverse number, distance 1 centimeter. And this is our distance in centimeters. So you guys feel free to do the conversions if you want inches as opposed to centimeters. But this one will go 150 centimeters. Okay, enough of this. Let's get back to this guy. So basically, when we bring up our serial monitor, which is up right now, so this is once I get to like 6 centimeters, it starts to go down. So it's starting to go down again, and then up, Okay, so basically, let's call it 650. So our range is basically 0 to 650. And we're just testing this. We're just giving you some output. I mean, you'd control motors. We're actually going to do that. We'll control motors, and we'll use the sensor values to remap the sensor values into something that the motor. So the motor will use impulse width modulation. Will go from 0 to 255. So it'll go faster based on sensor input. So I just showed you a little bit of that code. In a previous window. But okay, so our max is 600. We're still going to do 1024, but let's put 600 here. Let's work backwards. 600 here. So if the value is greater than 600, I don't know why. Oh, that's why we never put our buzzer pin to high. So it was our code. It was our code that was making so that the buzzer wouldn't go high. So now we have 600. So we're going between 100 and 600 for our different colors, and then eventually our buzzer. So 100 to 600 for our colors. So we've got 100 to, let's go, if we have it too close, then these colors will come on quick. So increments, so we have 500 to work with. Divide that by 3, and about 150 to 175. So let's go 250 for this guy, and 250 to 300 works, and then 300 to 450. No, that doesn't give us enough. So 100 to 275. 275, then 275 to, if we add 175 to 275, that gives us 450. And then 450 to, let's do 600 here. And then our buzzer goes high. So remember, our buzzer wasn't working, and I couldn't figure out why our buzzer wasn't working. So let's save our code, compile it, just to make sure we've got all our numbers right. And I'm hoping this one sensor isn't going to be broken up into 2 tutorials. But if it's too big for Vimeo, then it'll be broken up. And now let's upload our code. And actually, you know what? I want to get rid of this delay. This delay was good so that you could see the sensor values. It's uploading. That's why I can't open the serial monitor. Sorry about that, guys. I interfered with the upload. Let's try this again. There we go. Now it's successfully uploaded. Now we can open the serial monitor. Come on. There it is. And, once again, I'm moving my hand closer. And now I see green, yellow, red, and we have the buzzer. I don't know if you can hear that, but you'll hear it when we do the camera. So green, yellow, red, buzzer. Okay, so let's stop this guy. And let's take out this delay. Actually, what I'm going to do is just put 2 lines here and rem it out so that it won't be used in our code. And we will upload one more time, and we will save our code, and we'll go back to the video camera. So now we have our working code, and kudos to anybody who actually caught that buzzer was low in this last range value. And let me save this. And we'll go back to the camera. And then I'm going to compile this video, and I want to upload it today. I uploaded the last one yesterday, and that was just an overview. And I don't know about you guys, but I get a little upset with those the overview who's not teaching us anything. It's like, give me. Okay, now we're back here. We should have our working. So we're going to move this sensor over here so we can see it. And you notice that we actually got some buzzing out of there, which is great, fantastic. So let's put this. Okay. So we got to make sure all of our setup, and I'm going to take the camera off the tripod and give you a nice close-up of this when we're done. But for right now, we have our sensor, as you can see. And let me see if you can see my hand. And okay, you'll start to see my hand. No lights. So right now the sensor reading is less than 100. And as soon as I put my hand up there, we get the green light. Now I'm starting to move my hand closer. And hopefully it comes in the camera soon. You know what, let me increase. Let me bump up. Okay, so my hand's going to come into view. You can see the shadow of my hand anyway. That it's, we're over the sensor. Okay, nothing green. Nothing green. So my hand is about, I'd call it almost a meter for you European guys and gals. You know, there's a lot of women. L'Amour for Adafruit is very technical. So there's a lot of women that like these videos too. When I say guys, I'm including the gals in there as well. Okay, so it's about a meter, about 3 feet above, and as I just come down, boom, now the green light is on. So we're just less than a meter. We're just less than 3 feet. And I'm bringing my hand down more. And am I over the sensor? There comes my hand, and boom, now the yellow kicked in. And you can see where my hand is. And you see it's less than, right there, it's about 12 inches, or not even, probably about 10 inches. It's a foot. And we'll go down further as we get closer. So the yellow light is lit. Boom, now the red light is lit. And as you can see, we're probably about 6 inches away. And as I go down, now we actually hear the buzzer come on. And now if I go further, what you were seeing before, see now the buzzer has gone off and the red light is on. And as I get even closer, there's a quick drop in voltage. Now the red is off. As I get even closer, let me see. Actually, I can't make the yellow go off as I get closer. I guess it doesn't drop enough in voltage. But as you can see, this is our sensor, and now we have some output for it. And you guys should have enough knowledge right now to play with these analog sensors. This guy, this Sonic guy, has quite a distance, believe 25 feet. So if someone came into your driveway and was within 25 feet of this, you know, we'll make adjustments. We're actually going to do this sensor. I'm sorry we didn't get to all the sensors. I wanted to do the PIR motion detector. I wanted to do the analog joystick with the push button, but you know, there just wasn't enough time. So play with your sensors. I will do another video. I don't know whether I'm going to be able to do it today or not, but this one will be published today. I just published the other one yesterday. So this will get published today. And let me do that quick close-up. And I really apologize for this. so you can see how I have this connected. You see the red, the green, yellow, and red into the 9, 10, and 11 pulse width modulation pins, and then 12 is the orange, which is our buzzer. We come over here to the breadboard, so you can see how that's set up with the resistors. And then, so we're getting the power for each of these things from digital pins, and then we go back to the ground on the board. We have 2 ground connectors on there, and our power for our sensor comes off that 5-volt power connector and then back to a ground, and then the white one comes back to analog pin 5. And let me work the sensor while we're looking at this. Green, yellow, red, buzzer. Okay, we're back on the tripod, and well, actually, I don't know where I'm going to put this in, but I just wanted you guys to know, now that we're on battery power, we can unplug the USB. See, now we're just on battery power, and we see our project works fine. We're on battery. We could circuit board this thing, and I don't know what we do with it. Maybe we could pin it to ourselves and call it MySpace. Do not invade my space. If the buzzer goes off, that's my daughter in the background. Green is a safe distance. Yellow, you're getting too close. Red, you're invading my space now. You need to back off. And the buzzer is just like, okay. But anyways, you can see it's portable. Actually, that would make a perfect backup sensor for your car. So, let me see. So as you're backing up, you get a meter away, 3 feet away, you get the green light. As you get closer, boom, yellow. You've got about a foot away from whatever it is. And then red, you're probably about 6 inches away. And then, okay, now you're getting really close. And then everything shuts down, you stop. I guess you can be a backup sensor for a car. I just wanted to review the code as well. A quick review of the code. Basically, I'm not going to change any of these to variables right now. I'm just going to leave them the way they are. Let's do a quick review of the code. So these are our variables. Green LED, yellow LED, red LED, buzzer, IR sensor, sensor value. In our setup, we set our 4 pins, which is 9, 10, 11, and 12 respectively, to output. So green LED, 9, 10, 11, and 12, they're all output pins. We open up our serial port for our communications so we can read our sensor values, so we can make adjustments. Then we have our loop statement, our continuous statement that runs over and over and over again. That is sensor value, analog read, IR sensor. So we read IR sensor pin 5, analog pin 5. So we analog read that, and then we print it out to the serial port. And it's printing out to the serial port even if we have nothing connected, even though we're not viewing it. It's running that every time. And once we view it, we start to see it. Then we have our one big if statement. This is if else. We could have done a switch case statement here, but we did the ifs because we're going to use the ifs for processing as well. So if sensor value is greater than, less than or equal to 100, run this code. Everything off. Else, so if it doesn't meet that, it's going to go to the else. So else if it's greater than 100 but less than or equal to 275, run this code. So it has to be greater than 100 and less than or equal to 275. Then run this code. Else, if it's greater than 275, which means it's not 275, it'll be 275, it'll run this code. So if it's 276 and it's less than or equal to 450, run this code. So this is the code that we're going to run. We could make this code more efficient. We're not going to do that now. I want to get this video up. Else, if you can think of a way to, there are ways to make it more efficient. If you can think of what to do to make it more efficient, then go right ahead. And you can post your code on the comments if you'd like. Else, if sensor value is greater than 450, remember, if it's so 451 and it's less than or equal to 600, so if it's equals 600, run this code. Less than or equal to 600. So between 451 and 600, run this code. And here, between 600, or 601, sorry, greater than 600, 601 and 1023, then run this code. You won't get 1024. It's 1024 different variances, which includes 0. So that's why this is 1023 and not 1024, because 0 counts as a value. So if we have 1024 values and that includes 0, our maximum value is going to be 1023. And if it's that, then run this code. And it constantly loops through that. And without a delay, it loops through very quickly. As a matter of fact, you saw how quickly it loops through. See, very fast. Very, very. I don't know if you're catching that, because we're only doing 15 frames a second here. But it's going a lot faster than that. And you'll see that on yours. Okay.